All right, so yeah, we are recording and let's get started. So, good evening, welcome everyone to uh, this teaching doubt clearing sessions and problem solving sessions on our course Fundamentals of Automotive Systems. So, in this particular course, we'll be spending some time together discussing a few aspects in the course which we have discussed, and I will be happy to help you with the questions you have. So, in this particular course, we will be going through 12 weeks of content, and in week one, we will be discussing some things about the overview and uh, engines. Then up to week four and some part of week five, we will be working with engines. In this time period, we will be looking at the physical aspects of the engine, the various parts in the engine, and uh, some theory about it, like engine cycles, where we will be solving problems in thermodynamics related to engine cycles. Now, moving on from those points, then we will be looking at the automotive powertrain, that is the clutch, transmission, and rest of the things, where we will be looking at some problems related to transmission, and we'll move into brakes in the week 7. So, yeah, all right. So, we'll move on to the hey, is my screen not visible? Hold on. All right. So, all right. So, yeah, as I was saying, in first 5 weeks, we'll be looking at various aspects of the engines, and then we will move on to the powertrain and the other components in the powertrain, like clutch, transmission, and how the power gets transmitted from the engine to the wheels. We will be looking at uh, problems in week 2 about engine cycles, and later on in further topics like transmission, brakes, analysis of braking, design of steering using Ackermann steering geometry, and how the system works. So this course will be a mix and match of some. This course will be a mix and match of some theory discussions and some of the problem solving regarding to various components. We will also be looking at aspects like anti-lock brake system, in which we have been working extensively. So more details will be discussed in week 9, hopefully. So let us start looking at week 1's content now. Okay. Yes. So we will be reviewing the notes from the NPTEL course so that it becomes easy, and you can also ask me questions wherever you need to, or wherever you feel like. So, welcome to this Fundamentals of Automotive Systems course. As I was saying, here we'll be discussing in various aspects of powertrain, brakes, steering, suspension, wheels, and tires. So, in powertrain, we will be looking at the prime movers. Prime movers are essentially the the component which is directly responsible for moving your vehicle. So in powertrain, we have two kind of powertrains like conventional powertrain and electric and hybrid powertrains. In conventional powertrains, we are using internal combustion engine, which would work on fuel like petrol or diesel. And on the other hand, we have electric powertrains and hybrid powertrains, which will use mix and match of all these. So in electric powertrain, we will be having components like inverters, batteries, uh, and the electric motor, which will be driving the wheels. In hybrid powertrains, we will be discussing about different degrees of hybrid powertrains, like from a mild hybrid to a strong hybrid. How much of the percentage of power is coming from which portion? And there are powertrains like fuel cell based powertrain, which will you know uh, take hydrogen or something like that for fuel and directly converts it into electrical energy without the process of combustion, which is in contrast with our internal combustion engine. So once an engine starts and it generates the power, it has to be transmitted from the engine to the wheels. So in that, various components like clutch, gearbox, uh, and drive shafts would come in, which would finally take the power generated at the engine and take it to the wheels. Another important aspect of the vehicles are brake. Uh, so here we will be discussing three things. First is how a hydraulic brake system work. In that we will be discussing components of an hydraulic brake system and how do we make sure that even if we are not able to get full brake due to some brake failure, how do we ensure that the driver is still able to brake? Then we will be looking at air brakes, which are used in larger heavy commercial road vehicles. These air brake systems will these air brake systems are used on the larger vehicles due to their robustness aspects. Like even if there is a leakage, you can continue filling in the air and it starts compensating for minor leaks so that you can still operate the vehicle. And you can also work with tractor trailer arrangements like uh, attaching a trailer to your truck without risk of hydraulic fluid leakage. And then we will be looking at an important technology called anti-lock brake system. This also happens to be the core research area in our group, and I would be happy to discuss more details on anti-lock brake system at a later stage. That would happen in week 9. So, an anti-lock brake system is essentially uh, an control intervention system which prevents wheel from locking, and you want to avoid wheel locks because the wheel lock can result in loss of controllability. So you will not be able to steer the vehicle uh, even when you are intending to steer the vehicle in case your wheels have locked. So how do we prevent those and help keep vehicles safe on the road? So that is all about the anti-lock brake system. In steering, we'll be looking at steering mechanisms and we'll be discussing something called Ackermann steering geometry, which would enable us to uh, have our own design of a steering system. How would you design a steering system for a vehicle? So we'll be looking in detail into that, and we'll be discussing wheel alignment and how can you take a look at your tire of your car or the bus and figure out what kind of misalignment issues are there. From steering, we'll look at suspension where we will discuss something like quarter car model. There are different types of suspensions, so which are based on air springs or the normal springs, and even in the springs there are different categories of springs, which are used in suspension. The idea of suspension is to reduce the bumps and all on the road surface, and its impact on the occupant should be minimized. So with that intention, how do we ensure rigidity of the body, and how do we make sure that the road vibrations do not reach occupant, or mitigated significantly before it reaches the occupant? So that is what we will be discussing on suspension. And finally, we will also take a look at wheels and tires module, where we'll be discussing about how tires are important, and we'll touch up a little bit on the vehicle dynamics aspect. Our scope in this particular vehicle course will be limited to a single unit four-wheel road vehicle. So in each of the module, we will be discussing the components and the realization, how it is physically present in the vehicle with some diagrams and actual photographs. We'll discuss how it operates and we'll perform the analysis. So in these uh, sessions, we will, wherever there is some analysis portion, we will be discussing that analysis portion, and we will be discussing that analysis portion, and we'll solve them as some assignment problems at the end of each module. Uh, no, we do not need to write this. So these notes are actually available to you, and whatever I will be writing, if and when I will write, will be made available to you, everyone, by the NPTEL team. So these videos also would be going on YouTube. I hope you will be able to search that later sometime from tomorrow. So the NPTEL team would make sure that you will be getting all the material which I will be showcasing. However, these notes are actually available on professor's website, which you can download directly. And I think you can also download it from the Swayam website. So yeah, you need not write these things. All right, so that will be the structure in this course: discussion of components and how the things are realized in real vehicle, how do they operate, and analysis thereof. So in the problem solving sessions, in some of the sessions where problems would come, yes, Vijay, so let's go to professor's website, right? So uh, all right, you go to his website, and go to teaching, and you can look at this ED5160 fundamentals of automotive systems. If you go into it, you can click on complete handwritten notes, and these are the same notes which I'm using. I will be using few days, and some days I will be adding my own material, which will be made available to you uh, on email communication from NPTEL. So uh, yeah, you can download it from this website. All right. So okay, yeah, that can be done. All right, yeah. So I have pasted the link. I think from there you can go to teaching and get these notes. So yeah, as I was saying, we'll look at modules. In each module, component and realization, operation and analysis. From analysis, we'll be discussing some problems. So there are, I think, around 35, 34 participants in the group. So uh, how would you people like it to be? I can quickly discuss summary of it, which will take around 20-25 minutes for this week while scrolling through and talking about these things. Or if you have specific questions, you can unmute yourself and uh, you can perhaps ask the questions and we can go to that part. So I think let's spend some around 20 minutes to summarize the ideas which were discussed in this week. And then if you have further questions, we can take a look at it. Okay, so there is one question asking how to calculate the required torque to move a vehicle, say with the load of 2 ton, and what are the parameters to be considered. So uh, I think this discussion will uh, actually will be taken care in our vehicle dynamics course, but let me quickly summarize the process for you. So you can write a F equals to ma equation for the first thing. This okay. So the forces you need to consider in this are as follows. First force you will consider is yeah. So the first force you will consider is the force you need to push the vehicle. So Fx, that will be coming from the torque. So you can replace that Fx with the torque on the rear wheel uh, multiplied by two wheels because you have two wheels and uh, multiplied by the divided by the radius to get the force. This is the force which you are going to use in your favor. Then there are opposing forces. So these opposing forces include first the aerodynamic drag, half into rho into CD into V square, where V is your speed, CD is the coefficient of drag, and rho is the density of the air. So aerodynamic drag is one force. Second force is the rolling resistance of the tire, which is say Fr into the weight on the tire. So the normal force you have on the tire because of the weight of the vehicle will contribute to a rolling resistance force. This rolling resistance force is originating because the rubber in your tire gets compressed and decompressed. So the heating happens and you lose some energy to it, right? That is lumped as something called as rolling resistance. So no, I'm not solving the problem. I'm just talking about it. So give me 2 minutes. I think I'll start. I'll get something to write on. All right. So just hold on for 1 minute. All right. All right. So uh, Okay. All right. Uh, yes. So, are my notes visible? Can you confirm? All right. So, yeah, we'll go with the questions one by one, Vijay. So, thank you. So, yeah, how do we calculate? So, we have a vehicle, let's say, right? There is the aerodynamic drag, and your tires will have rolling resistance. So, this rolling resistance is equal to Fr into W, where W is weight of the vehicle. All right, and this is the aerodynamic drag. So you say that your mass into acceleration is equals to the force you are giving Fx for driving the vehicle, right, minus the forces which are opposing you from driving. So Fa and minus Fr into W. So now you write F into A equals, let me write force as torque divided by radius, minus Fa is half into rho CD A V square minus Fr into M into G. Alright. So where M is mass of the vehicle, A is acceleration of the vehicle, tau is the driving torque, CD is coefficient of drag, A is frontal area of vehicle, Fr, its value is approximately 0.002, is coefficient of rolling resistance. And then tau is, okay, tau I have written, R is the radius of the tire. Okay. So, you can plug in your mass, your desired acceleration value, the frontal area of the vehicle, coefficient of drag, density of the air, and the rolling resistance value. And using this equation, you will be able to find out. That was the question. So, the question was how to calculate the required torque. Uh, to move a vehicle. Right, so this equation can help you calculate. All right, so Next question is from VJ asking from week 2 assignment, how do you calculate thermal efficiency? So, actually, week 2 assignment we will be discussing next week. I also have to prepare for that, and I can better answer you questions for the week in that week for compression ratio of 8 in the uh, air standard auto cycle. So, if we have more questions on week 1, I think I would first prefer to discuss that. And the reason for submitting the assignment, is it so? Thomas? No, week 2 assignment. This looks ridiculous. Okay, so all right, if that is the case, uh, which I was not made aware of, let us go through the notes and try to understand it together. Is that fine? Uh, so when is the week 3 deadline? Can you just tell me? All right, okay. So I think from then it will be slightly easy to work with. Uh, Okay, so let's start discussing engine cycles because this, and then while we are discussing engine cycles, we will be will come to that. So the engines essentially week 2 Q3 has no right answer. Uh, by and large, these are I'm this has been like I don't know, fifth or sixth rerun of the course. So in good faith, at least I hope the answer is fine. But there should be some right answer. Unfortunately, I cannot tell you what the right answer is straightforward. Uh, I my discussion style would be to talk about related stuff. So if you have a specific doubt, then that we can discuss. So yeah, what is a thermodynamic cycle, and would one classify an IC engine as an open system or a closed system? So these are the questions I think we will be discussing in week two's engine cycles portion. So in air standard cycles, these are the assumptions which are made. First is working fluid is air. Air is treated as an ideal gas. By the way, if you have genuine uh, concerns like week two's question 3 has no right answer, kindly write on the forum. The TA on the forum, if any, should be able to respond you. Okay. All right. So these assumptions are made. First assumption is working fluid is air. Air is treated as an ideal gas. Combustion process is described by heat addition process. The heat rejection process is used to restore the system to its original state. So since it is a cycle, we have to go back to the original state and the cycle should continue. And then all processes are internally reversible. Constant or variable specific heats can be used. So uh, here we are looking at an Otto cycle. It is used to characterize the operation of a SI engine. right? The SI engine is essentially which an engine which is spark ignited, right? It's used for gasoline engines or petrol engines. So if we look at the pressure versus volume diagram, this is how it looks. So there is first, you can say there is an intake of air in which so VTDC is the lower volume when the cylinder is just touching the cylinder head, and VBDC is the bottom position, okay, of the piston. So as the volume increases from VTDC to VBDC, that is when the piston moves from top to bottom, uh, there is some intake valves open, and intake is the process where we are taking in the fuel air mixture. Then as the volume decreases, there is compression happening, and when we almost reach the VTDC, that is the top dead center, sorry, yeah, ignition happens, that is the spark plug ignites the fuel air mixture, and because of it combustion happens. As the combustion happens, the fuel air mixture starts expanding. With this expansion, the power is put into the system, that is combustion energy essentially pushes down the piston, converting that chemical energy to mechanical energy. And while this is happening, we'll reach the bottom center. And when again the piston is moving in the fourth stroke, exhaust valve should open, and the consumed air fuel mixture now is just in form of uh, exhaust gases will be thrown out. Okay, so if we look at this is how the process diagram is. If we were to convert it into a thermodynamic cycle, we can look at this diagram, right? This PV diagram, where in process 1 to 2, the intake is happening. In 2 to 3, we are burning the air fuel mixture, so heat is coming in, right? As we said here, a heat rejection process. So heat addition process and heat rejection processes are used. These are said to be at constant volume, right? We go from 2 to 3 as a heat addition process, and then from 4 to 1 we have a heat rejection process. So what are these processes in the Otto cycle? Processes are as follows. If we draw the corresponding TS diagram of above PV diagram, this is how it would look. In the process 1 to 2, we are looking at isentropic compression. In 2 to 3, we are looking at constant volume heat addition. Then in 3 to 4, we are looking at isentropic heat expansion. And in 4 to 1, we are looking at constant volume heat rejection. So, so you can look at the efficiency, thermal efficiency of a standard Otto cycle is given by W net divided by Qn. So how much energy we are giving in, that is Qn, right? And W net is the work done net. So if you look at this entire process, and yes, the final expansion, final answer would, you can calculate using this expression, where eta thermal Otto is given by 1 minus 1 over this R power gamma minus 1. So where R is your gamma is Cp by Cv, and R is the compression ratio. So it's fairly straightforward. So, okay. The I hope this will help you in answering that. Then looking another question. Uh, so do we have derivation for exam? I have Ronak. I have no idea how the NPTEL conducts its exam. I know it's proctored and you have to go there on the location. As a course, we have by and large given MCQs and one or two derivations. I would recommend you to go through the derivations in this, and you know, if you can go through the derivations, that should be helpful to you in the course material. Given that it's an online exam, there is high likelihood that it will be similar to what you have been working in the assignments. So you might need to derive or solve a small numerical. Ideally, it should not take you more than 5 minutes. The questions are designed in that way. Uh, yeah, so I'm just telling you what formula to use uh, so that you can solve the question, but I leave it to you to solve the question exactly, because there is nothing much in it. It's just this example in the box, uh, you know, uh, which will help you. Uh, yes, Ganesh, you would like to say something? Uh, there is some traffic noise. I'm going to mute you if there is no question. So, uh, when can we see your assignment scores? I do not deal with the logistics of the course. I think, but after your submission deadline is over, you should be able to see that. Aditya asks, can you tell us about the desmodromic valves? So, okay, let's go to that section. All right. So let's look at the valves and valve assembly. In this, all right. So the valves are used to introduce. Uh, Hello, Ganesh Dekar, do you have any question you would like to ask? Uh, yeah, please, you can type in the message or raise your hand uh, if you want to ask a question. Yes, so coming to the valve assembly, there are two kinds of, valves have two functions. First is to introduce the air fuel mixture inside the, or introduce air inside the combustion, inside the piston. And second is to remove the exhaust valves. So, okay, all right. So, desmodromic valves are the valves which will have some floating element. Uh, so, for example, let's take a look at this particular valve. You can see that there are springs in here which are helping us to keep the valves closed, and to open the valves we are using this rocker arm shaft and the rocker arm, which opens or closes the valve. But to seal the valve, we are using springs here. So in these desmotromic valves, if I remember, it would replace uh, yeah. So all right, I think I'm not remembering too much about desmotromic valves, but the idea is that you use other mechanism to keep the valve shut rather than relying on the springs, which may age with time, and hence it will give you better performance. So I think what I will do is I will add more material on the desmotromic valve so that you can take a look at it better when we upload the notes. Okay. So I have noted it here. More material will be added on the desmotromic valve so that it will be so that you can learn more about it. Uh, so that is Aditya. All right. So one portions aside, do we have more questions now? For yeah, we will ask theory and uh, both the questions. Yes, Ludo in GK.
Yeah, yeah, I'm Ranjit here, sir, from Ludo in GK.
Yeah.
So my question is, so regarding the two-stroke engine, you
Okay.
mentioned about the crankcase scavenging, where the fresh air fuel mixture get into the crankcase through inlet port, and it will pass through the other port to the there. So you mentioned it will be also get compressed inside the crankcase. So based on the schematic diagram, I see there is a more volume. Uh, will that be a really a compression, or it is just used as a passage uh, uh, to go through the cylinder volume? That's my question. One question.
No, in which diagram? I have scrolled it through the diagram. Can you
So on the
clearly?
diagram on the left bottom, where you
Okay.
mentioned fresh fuel air mixture.
Ah, yes.
Yeah, yeah. So, so during the course you mentioned it will be also that area will be also act as a compression chamber, so that the fresh air fuel mixture will be get compressed in the crankcase chamber.
Mm-hmm.
So it just needs some clarity. Will that be because the volume seems to be too high? So will that be really compression happens there, or it is just a flow through process?
Uh,
Uh,
so see, a little bit of compression will happen because the piston is coming down, right?
correct,
Right. But that is not the primary uh, method in which it is working. So
right,
uh, when the piston is coming down, some compression would happen. This compression would also uh, facilitate the flow of air from the crankcase up in the combustion chamber. And when the piston is moving up, uh, the exhaust gases will go out. So as you can see, there is also risk of exhaust gases taking some air fuel mixture with it. So, you
Correct.
know, right, reducing the efficiency.
Yeah.
A little bit of compression will happen because of the motion of the piston, but that is in essence to facilitate the flow of air fuel mixture into the main combustion chamber, right?
Okay.
Okay.
Got. Yeah. My another question, sir. So as we know, we have multi cylinders for four stroke. In two stroke also, we have any example of multi cylinder? The reason being is if the air fuel mixture pass through crankcase, so how we will split between one cylinder and the other cylinder? That's my other question.
Okay. If I remember correctly, big ships do use multi-cylinder diesel engines. They also happen to be two-stroke engines. So, so your exact question was, are there any examples of such kind of engines or?
Yeah, yeah. So yeah, you answered me. So in the ships or even in the railways, it should be a multi-cylinder.
Yeah,
So
yeah,
yeah, maybe I will go through some material to understand how they split between one cylinder and another inside the
yeah.
crankcase. Yeah, maybe let me work on it. Thank you, Professor.
Yeah, I'm not the professor actually, but it's fine.
Okay,
All right. So I work with him.
okay, no problem.
Yeah,
Thank you.
one of a good idea, if I were to think aloud here, is that you take this burnt exhaust gas from
Mhm.
say three cylinders and push it into fourth cylinder to burn out the residual,
Oh, okay,
right?
okay,
It will, in a sense, enable you to get little more uh, efficiency out of the process. However, uh, as you would see when professor would compare in the class two-stroke versus four-stroke engines, it's a much better and much more efficient technology. So recent offerings from brands are allowing you to directly, instead of sending in the fuel air mixture, as
mhm,
I think in the four-stroke engine, right here, if you can see, we are introducing the fuel air mixture. Instead of that, we just introduce the air and we directly inject the fuel. So it can be diesel, like right. So or it can be petrol. So TGDI or TSI are generally the brand identities associated with right. So TGDI is turbo directly into. Wait, is it turbo? Yeah. So direct gasoline injection is the idea
okay,
where you are not mixing the air and the fuel, but the process of injection at high pressure would, as he has written here in compression ignition engines, a fuel injector is used and fuel self ignites. But in a direct gasoline injection, a fuel injector is used to push in the fuel and a spark is used to ignite the fuel. Right. So this gives you some better advantages, and you can switch on or switch off certain cylinders. For example, I think offerings from Skoda and Volkswagen Group do have such engines. You can take a look at them. So, Raunak Raikar. So, we will be uploading after the session is over. I will create a YouTube channel and upload it on that. Uh, I don't know how to communicate the name of YouTube channel to you, but it will be written. I think last time I did, it will be written as NPTEL. Let me write it down. NPTEL. Uh, I will write it as NPTEL FAS and my name. So this is roughly the name of YouTube channel where you should be able to find. You can search my name and hopefully get there. The channel is not created yet, uh, but I will do it after this session and upload this video. Okay. Then we have a question. What is the function of a heater plug in the uh, cylinder head? So our yes, Vivek Raghav.
सॉरी सर कुछ बात नहीं है
अरे ठीक है. Uh, yes. Right. Mm, okay. So uh, Vijay, can you ask me? Can you help me with your question? What is the function of heater plug in the cylinder head? Did we discuss that in the class? On page 6, huh? Okay, thanks. Okay, great. All right. Okay, I'll get back to you on this question also. I'll just note down the questions if I am unable to answer. Will be the answers of which will be written in the uh, uploaded handout of this session. Okay. So, heater plug function. Okay. Yes, Deepak.
Sir, I would like to ask you one question about the piston rings. Like in our single cylinder engines, like motorcycles, there are three piston rings are there.
Okay.
Some compression rings and oil rings.
Yeah.
So the number of rings,
Mm-hmm.
including all, oil ring and compression rings,
Mm-hmm.
they are similar in every cylinders, even though there is a four wheeler or trucks or tractors or anything, any kind of vehicles. So what are the aspect regarding this? Because I want to know compression rings are two and oil rings are one.
Okay.
Okay, so is it same for in all cylinder cases or on all different automobiles vehicles? And what is that reason if there is change?
Okay. So you're saying that we have uh, three rings, right? And is there any difference? Like different automobiles will have different number of piston rings,
Yes, sir.
right? So I think the idea behind piston ring is to improve. I mean, the contribution of it will be in improving the efficiency of uh, of the combustion process by reducing leakage and also to keep things well lubricated, right? So as long as your function is getting satisfied with these, it's okay to have the number of rings we have currently. Now, if I were to think as a designer, how will I put uh, how will I decide how many number of rings I need to put? So if say for some reason I want to take my pressure at which we will be doing combustion, say by adding a turbo, in such a scenario, I may need to either make my rings slightly bigger or maybe add more rings to do the job, right? So that uh, Okay, so as a designer, we would like to make a choice depending upon the criterias and the function it follows. I hope it slightly answers the question.
Yes, sir. Actually, I want to know that what kind of design criteria you decide while designing piston rings and pistons
Okay.
for any kind of vehicles. So
Uh,
that parameter I would like to know.
uh, okay, so let me note down the question. We'll try to get back to you. I am a brakes design fellow, unfortunately.
No issue, sir. Just
Yes.
I want to share because many people are they are students, there are some faculties,
Uh-huh.
and they are not having such like question because they just see in the theory lectures. So there are some piston ring, there are some compressor rings, oil rings, and they
Mhm.
have their own functions.
Right.
Okay, so but in case how a designer or how a company they decide for a small cylinder size, they decide two rings or three rings,
Mhm.
or if there is a higher cc version
Mhm.
of a cylinders or large capacity cc volume,
Okay.
so how they design or how they evaluate there is a combustion process and there may be less chances of leakages or maybe more chances of leakages like that.
Okay. So, yeah, as a designer, I can suggest you one of the design philosophies called form follows function. Right. The idea there is to uh, design the mechanical or the physical system or even software it applies that it should do the job we want it to do. Right. And with that philosophy also, we have been working in the brake software domain, which predominantly happens to be my area of work. So if you need more piston rings, you want to ask, do I really need more piston rings, or do I need to make changes to my existing piston rings? Because a design process is not just about getting things technically right. Sometimes financial decisions are involved. We also have to design for assembly. That means every ring I add to the system, of course, it will bring in, however small it may be, some level of friction. And sometimes the trade-offs are worth it, sometimes they are not worth it. So we'll have different criterias under which such design decisions gets evaluated, and finally we arrive at where we are.
Okay, and what about the material used for that that rings?
Uh,
Is there any new invention about material?
oh, again, I'm not aware of that.
Okay,
Perhaps
sir.
what I will do is I'll discuss with the professor tomorrow and
Yeah.
get back to you. Okay.
Okay, okay, sir. Thank you, sir.
Okay, yeah, thank you. So I hope I should be able to have all of your email IDs at the end of the session. Uh, so I've written down as how are the number of piston rings decided? Are there any innovations in materials?
Yes, sir.
Okay, all right. So okay. Hmm. VJ asks, will we be covering how electric vehicles work? So I think that is one of the modules which is not part of this course. So what I would do is, if all of us agree on it, that anyway the 2 hour session which we are expected to discuss for next uh, 11 weeks, even from today, I can read up and bring in some module on electric vehicles and we can cover it here. Is that fine? So maybe in each session we can spend, not from today, but from next session, each session if we spend around 20-25 minutes on electric vehicles, I think that should be helpful for all of us. So yes, Vijay, that would work for me. I hope others would like this idea. So Uh, yeah, we can
When we
certainly
are
do that.
when we are going to meet again, sir?
So every Monday, we will be having this meeting from 6 to 8. Uh,
Okay, sir.
Honestly, this it feels slightly long time for 2 hours, but let's let's try to make the best out of it. Okay.
Yes, sir.
Okay. All right. So, uh, yeah, more questions? Yes, Vivek.
सर अब मेरे को यूट्यूब चैनल के बारे में आपसे जानना था। यूट्यूब चैनल का नाम बता सकते हैं आप अपना एक बार और?
हाँ, मैं कोशिश कर रहा हूँ कि मतलब नाम मैंने अभी डिसाइड तो ये किया है। यू कैन लुक फॉर माय नेम पावेल गौरकर, PAVELGAURKAR. You will find it from tomorrow. Sometime tonight, I will make the YouTube channel. Okay.
ओके सर।
All right. Yeah. Thank you. Uh, so I'm using on iPad this app called Notability, and I'm using AnyDesk to share my iPad to my Windows computer. Unfortunately, that's how I have to work with. So, what topics would you prefer to cover on electric vehicles? Like, what are the expectations from group of around 20 people we are here? If you can tell what you would like to learn about electric vehicles, I'll make a note of those things. Okay, how does an electric vehicle work?
Sir, battery management system.
Okay, uh,
Because battery when you are using that time it's get heated up. So
mhm.
cooling methods and how can probably longer its life.
Okay, so yeah, that's a great question actually. So, if we is your background from mechanical or uh, electronics? I'm just curious so that I
My
can tweak my answers.
I'm from mechanical, sir.
Okay, all right. So, all right. So, yes. So, if we consider a battery, uh, in a battery we store electrical energy as uh, chemical energy, where we have cathode, anode, and the electrodes. Sorry, cathode, anode, and the electrolyte. So, when you want a current to flow in your external circuit or circuit inside the battery, we have the movement of ions. So these ions will move from one electrode to the other, and in doing so, that happens in the medium called electrolyte. So there is interface at which reaction happens, and as your battery ages, those reaction sites gets deposited with unwanted, uh, so you won't have one reaction, you'll have multiple reactions because batteries are extremely complex systems. So some unwanted uh, reactions would also occur in the battery, and this would lead to degradation of battery eventually, right? So you have something called VI characteristics of a battery. Let me draw that for you, and we'll try to understand. So this is voltage and this is current. So it looks something like this. Okay, all right, I think. Okay, something like this. So initially your voltage will be very high when there is no load, no current being drawn, right? This area is where you are safe to operate. Okay, so our idea, the battery management systems use is essentially to make sure each cell is operating in its safe operating region. This would ensure that battery would last longer, and of course as the temperature increases, because lots of current is being drawn from the battery, uh, these reaction rates would also get affected and so on. So your depletion would happen much more faster. So we have done, okay, I think our department offers one of the courses. I will pull in some material for the little discussion on battery, and then we can have some more discussion on the BMS. So you would require cooling in a way that it will then limit the, sorry, it will help us in having better reactions in the battery and improve longevity. Uh, so as I was telling you, if say this happens to be your electrode, say I'll just draw positive here. This region is where, right, the surface area on of the electrode is where reactions would happen. So as the battery ages, some small deposits will come in, which will degrade your battery. Right, that is something which we don't want. So if we keep the battery in better temperatures, these reactions would occur slower, hopefully, and help us better. So let me list down. We have BMS, packaging, and thermal. Then we have how does a hydrogen fuel cell work? So
Sir,
yes,
can you cover on IDC, sir? Indian driving cycle.
okay. Let me try. I am also constrained with bandwidth. IDC.
Okay, sir.
Okay. Uh, so I'm almost in the finishing process of my PhD. But I think we have done some work on driving cycle. I will uh, at least talk about it and guide you to appropriate references. Okay,
Sure, sure, sir.
so the
Thank you.
idea behind driving cycles uh, is that you can utilize driving cycles to predict how your vehicle will behave in the real world scenarios. So these driving cycles are somewhat standardized to mimic, say, city driving conditions or highway driving conditions of a typical vehicle which will move uh, on our roads. And given it's our Indian roads and our traffic, uh, we cannot just directly borrow someone else's driving cycle and use it. For it. You can clearly imagine that you cannot have a European driving cycle uh, to test your electric vehicles battery range, because their driving will be very different than what our driving is. So that is why we need our own driving cycle which reflects the driving of a typical Indian user. So but what would you like to know on driving cycle? Can you slightly elaborate so that I can
Uh,
get back to you
like
better?
like first, just the basics of driving cycle
Okay.
and how exactly it is used to determine the life of the battery as such.
Okay. So see, the driving cycle would determine how you are consuming energy, right? You can have uh, yes, Raghav. Let me finish my point, then you can ask your question, Vivek Raghav. So as I was saying, the driving cycle would help you in uh, taking care of the consumption and gear shifts. So driving cycle will have braking phase, acceleration phase at different levels, to different speeds. So if you run the driving cycle again and again repeatedly, you will get a good picture of what is going to happen in real world scenario. So that is a rough cut understanding of driving cycle.
Okay.
Okay. Yes, Vivek, you had a question.
Thank you.
सर मेरा क्वेश्चन थोड़ा-सा इन लोगों से हटके है, टॉपिक से थोड़ा-सा हटके है।
हाँ, बोलिए।
सर जैसे कि जो इलेक्ट्रिक व्हीकल्स होते हैं हमारे,
हम्म।
उन्हें चार्ज करने के लिए बेस्ट वर्किंग क्या रहेगी? मतलब ऐसा क्या करें जो बेस्ट चार्जर बने और बेस्ट वर्किंग करे? जो मतलब कम टाइम में बेस्ट चार्जिंग करे?
सो हाँ, जैसे आपने बोला कम टाइम में बेस्ट चार्जिंग करें. सो द क्वेश्चन ही इज आस्किंग इज, आई होप आई विल आंसर bilingually. It's okay, right?
यस सर, यस सर।
Yes, all right. So as he asked, his question is, how can we make a best charger for electric vehicle? So uh,
यस
is
सर।
right. So first thing, and later on he talked about best in terms of charging time. So as a designer, I would always ask best in what terms. Okay. So that is why we get different charging modes, even for our smartphones. That's a more relatable example. The slower you charge your batteries, it is better for your batteries, right? In terms of longevity. So the fast charge technologies which are available today will take you really fast, uh, right? It will take you really fast from extremely low battery SOC, that is state of charge, to a reasonable SOC, say 30-40%, and then it will slowly charge. So the slower you charge your battery, the better it is for your batteries. So if your vehicle can know if you are putting it for an overnight charge on a slow charger, which is what you get with your uh, home pack, versus the uh, like they have different names like supercharger or hypercharger, whatever, the fast chargers which are there commercially at places like malls and all. These fast chargers would uh, take your battery level from very low level to a medium level as rapidly as it can, and then it starts charging slowly. So you are essentially looking for an optimal trade-off between how fast can you charge, how good it is for your battery life, because you want it to be charged fast, but you also don't want it to be depleted. So again, borrowing from a smartphone example, what they do now is split the battery into two different cells so that you can parallelly charge them, right? Charging in parallel allows you to push in more energy or more current from your charger, and that's how we are looking at 120 watts and almost 200 watts in phones. So yeah, charging batteries in parallel is one way to go about it. And which particular branch, right? If you have a large EV battery, it will have multiple cells connected in series and parallel. So uh, cells connected in series makes a branch. Branches connected in parallel makes the battery pack. So which branch you charge will also determine how fast can you charge. So it would depend on how cleverly you design your algorithms while clearly knowing your optimal trade-offs. So if you are more interested in asking questions about what is the best way to do this, I would recommend you list down in what sense you want it to be best, and also uh, write and do some formal training on optimization. I think you'll find some courses on NPTEL regarding optimization. All right. So I hope that answers your question slightly.
Sir, I have one question regarding the same only.
Okay.
As you said, there is a dual split charge system is there.
Right.
So that battery is divided into two parts only, na?
Yeah, in that case, it's divided into two because we are talking about a phone. But as I was saying, for larger electric vehicle batteries, each lithium-ion battery would give you around what 3.3 to 3.7 volts, right? But you are running your systems at say 24 volts or 48 volts or even higher voltages. So you are connecting them in series. Each cell, like a bunch of few cells connected in series. Then you have just one series is not enough to give you sufficient current. Then what you do is you add more such branches in parallel to create a bigger battery pack which will meet your voltage and current requirements. Okay, so each branch is treated as independent entity by your BMS for charging purposes and all, but to your motor it is perceived as one single source of energy which is giving it the current it needs to accelerate you or keep you cruising.
So it is only dual system, or we can make it triple, or
Yeah,
um,
sky is the limit. I mean, battery pack size is the limit. You can make it multiple. So you can have, for example, if you look at uh, say a scooter from Ather. So it will also have some cells in series and some cells in parallel. I don't know if they are telling how many cells in series and how many cells in parallel, but I think you should be able to find that information somewhere. So mhm. Yes, so you have multiple cells used in series and parallel. You'll have to dig in little bit information, but I'm sure you can certainly find how many cells in series and how many in parallel. Okay.
and there is one more system that during the traveling we can charge our batteries.
Yeah, so that is called regenerative braking. Are you talking about regenerative braking?
Yeah.
Yes. So the idea in regenerative braking roughly is that when you apply the brakes, instead of using the friction brakes, you utilize the kinetic energy of the vehicle and treat the motor in generator mode. So whatever power you are getting from the motor in generator mode is used to charge the battery. It helps you in increasing your battery life, and it will tell you. I mean, you can save up some of that kinetic energy and put it into your battery. So that is the rough idea, and I think let me see if I can find something on regen in more detail for the small series on electric vehicles, which we can try out.
Because I have to ask this question because recently I
Mhm.
visited. I traveled around 1,200 kilometers,
Mhm.
and if I using electrical vehicles, then it is impossible to me travel within 2 days.
Okay.
So I have to take a break of 6 to 7 hours, and I have to charge my vehicles, and I have to go ahead. So in
Okay.
that case, I should have a replaced battery stations available in the like a petrol pumps.
Okay.
So is that a kind of facility could be available in India?
Uh, it
Replaceable battery.
it see those are also questions to ask more on the commercial side than the technical side. So battery swaps will be one of the ways to work with. Like for scooters, those models are there, but for cars, of course, it's going to be extremely difficult, uh, right? And even if we come to that stage, the economics problem becomes who owns the battery, right? And how will be that costs and all will be taken care of. So uh, we need more discussions on business side as well to make it a viable choice, right? Technology alone will not be able to take us that far. So it has to have some business case to finally trickle it down into the market reality. Uh,
Okay, sir.
okay. Vijay asks also another subtopic would be on driveline. I believe there is no gearbox in electric vehicles. So electric vehicles may or may not have gearbox. Okay. Sometimes you need one to step down your RPM and improve your torques, right? Because of the motor type you are using and motor size you are constrained to work with. Sometimes you do not need gearbox in situations like you are working with in-hub motor. So for example, even if we take scooters, you take a look at either it's driven by belt and it will have single gear or something. But if you look at by and large offerings, I think from TVS, it uses a hub motor, right? RPM is revolutions per minute. So, all right. Yeah, so gearbox may or may not be there. Again, when we look at transmissions, we will discuss why a gearbox is needed in first place. The basic idea is that your engine will not give you peak efficiency at all the RPMs or right at all the speeds. Then you need to have something which will get you what you want on wheels in terms of the torque and the speed of the uh, speed at the wheels, but also keep your engine operating to the best of its condition, right? So roughly around 3000 RPM. Yes, I think someone raised the hand. You can. Yes, Sachin, you can ask question.
Hello, sir.
Yes, hello.
Sir, in the second week, our professor discussed about the two-stroke petrol engine,
Okay.
and sir was mentioning about uh, exhaust gas dilution with the charge and
Uh,
getting out through exhaust port,
okay.
leading to lesser efficiency of two-stroke engine, and was also talking about the uh, high specific fuel consumption and incomplete combustion
Yes.
happening because of this dilution.
Mm-hmm.
Sir, out of my curiosity, I'm just asking
Okay.
if it was a two-stroke diesel engine,
Uh-huh.
and through inlet, if we send compressed air,
Mm-hmm.
compressed air, just air, not the air fill mixture,
Okay.
and if that compressed air is used to utilize to push the exhaust gas out completely, and even if the exhaust gas even if the air fresh air goes outside through exhaust port,
Okay.
there wouldn't be any problem as well. So
Uh,
if compression of this air and the fuel injector injects the fuel, and if compression happens like that, would it increase the efficiency?
okay. I'm also thinking with you here, so do not take my answer at face value. Uh, but let's try to.
Like, did I
Uh,
put my question clear, sir?
yes, yes, yes. I get the question. So you are essentially saying instead of uh, uh, if we push in some compressed air from the outside, can we get the burnt gases out in a better way? And you're also talking it in terms of diesel instead of uh, the petrol engine, right? Am I
Yes,
correct?
yes, sir.
Yes. So let me think with you here. If you do that, your combustion efficiency will certainly improve. Okay, but that's not the only thing. You're adding one more process to it, right? So if we look at fundamental difference between a two-stroke engine and a four-stroke engine, okay, uh, so what is the fundamental difference? A two-stroke engine is much more simpler in construction, right? It's inefficient, but it is very simple to construct. when compared to a four-stroke engine, because see, there is absolutely no need of any valve here, right? And we have mechanisms to drive the valves, as we see here, right? There are valves, the springs, and the camshafts which will drive the valve. There is timing belt which will make sure that the strokes are synchronized with valves opening and closing, or the other way around, and when to put a spark and things like that. So uh, these are all the processes we are adding in the process of combustion to ensure that we are getting a more efficient engine. So if you say, let's look at this diagram, right? If we increase, if we somehow put the uh, compressed air inside, then what would happen? It will take away the burnt exhaust gases, of course, but it, because of the motion of compressed air, it will also take some fresh fuel air mixture with it, right? Because moving air would result in drop in pressure, right? So that pressure differential will take some fresh mixture with it. So there is not much escape in it because there is no valve shutting off the pulling in of fresh air uh, fuel mixture, right? So that is what I can think over the head as of now. Okay.
Yes, sir.
Uh,
Sir,
uh,
and one more doubt, sir.
mhm.
Sir, in diesel engine, we intake only the air, no, sir. Only at the end of the upward stroke, the fuel will be injected by uh, fuel injector. Is
Right.
uh, so only the air will be wasted, no, sir.
Yes, yes, yes. Okay, yeah, that was your point, right? So you want to do injection in the two-stroke engine instead of pulling in pure air mixture. We are just talking with the air. Ah, okay, sorry, I missed out that point. I was looking at the diagram while trying to explain.
Yes, sir.
Uh, okay, fair point. So maybe let's try to find out how a two-stroke diesel engine works, right? In the course we have talked about it, and your idea does seem to uh, make logical sense. Perhaps someone might have tried it. Okay. Uh, so maybe you can look up two-stroke diesel engines and see how they are doing it, and it will tell you the answer of if they are indeed doing the way you are thinking, or you are uh, or there might be some issue with the logic which you will understand.
Sir,
Yes,
RPM full form is revolution per minute, na?
yes, yes, yes. That's what I said. Yeah. So yes, you're right.
Thank you, sir.
All right. Okay. Do you think SI and CI engines will become obsolete? Can't say too much. We'll find out. That's an opinion question rather than technical question. How can we evaluate the efficiency of an EV gearbox? The idea is same, power in, power out, right? Any efficiency definition is literally that, what we are putting in and what we are getting out of it. So you'll say how much power you are obtaining at the motor end and how much power you are obtaining just outside the gearbox. That would tell you how much you are losing out in the gearbox. All right. So can we manually calculate it? See, manually calculation, it takes ideal uh, assumptions. So the question is, can we manually calculate the efficiency of an EV gearbox? So you need to make measurements in order to uh, calculate. So for example, if you uh, let's think together. You have a motor, it's connected to a gearbox, and you are getting power out. What I would do is I will calculate how much power my motor is drawing by measuring my voltage and current at the input side of the motor. Take it, take that as the energy which is being consumed, and on the other hand, I will connect my output of the gearbox to a dynamometer which has torque measurement capabilities. So I will measure output torque, right? And this output torque I can use then to see how much power I am getting out of it. I can calculate how much torque I am producing at the motor using the current, right? There is some relation with it. So uh, taking how much energy I am putting in and how much energy I am getting out, I can compute it. Uh, but yeah, you need to proceed experimentally with it. There are more sophisticated mathematical models which will allow you to do that, which I am not aware of. But perhaps you can take a look at it. Okay, so maybe I can, when we go to the section on, you can make note of this question. You can, let's revisit this question when we discuss the transmission, because transmission efficiency is something which we will be looking at, I guess. I don't recall it perfectly now, but I think we will be looking it in later weeks. So week 7 says transmission. So somewhere in week 6 and 7, we'll be looking at the transmission, and I think in that section there can be some discussion. Okay. Yes. Okay.
Sir, can you hear me, sir?
Yes, 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 I can.
Sir, I have one more doubt.
Mm-hmm.
Actually, I went on an internship. Actually, I'm studying in Coimbatore Institute of Technology near
Okay.
Coimbatore. I went on an internship on a company in a company called Bezaris, where they are the manufacturers of gearboxes,
Okay.
EV gearboxes. I
Mm.
worked on a project on incorporating something on gearbox.
Okay.
They gave me the input as the gearbox input shaft
Mm-hmm.
is connected to a 10 kilowatt motor,
Okay.
and the shaft input shaft is like what to say runs at an RPM of 7,000 RPM
Mm-hmm.
and produces a torque of 110 newton meter. Is this possible, sir, with a 10 kilowatt motor?
10 kilowatt and 100 and
110 newton meter of torque and 7,000 RPM.
okay. So you just do power matching, no?
Yes, sir. But, when you use the formula that is 2 pi nt by 60 formula you are saying, is it?
I also don't recall the formula top of my head.
Okay.
Okay, but
Uh,
see,
yes, sir.
if the claim is correct, the input power should be higher than the output power, right?
Yes, sir.
So if that matches to a reasonable extent, then I think uh, that is fine, right? You should be able to pull it off. Otherwise, see, it should not violate the conservation of energy. There can be losses, but there can never be a gain unless you are
Yeah.
explicitly putting it inside. So, yeah, trust the basic physics on that.
Yes. So what I'm asking is, will the electric motor with 10 kilowatt power
Uh-huh.
can generate this much amount of torque at this 7,000 rpm? Like if we use the formula, na, it is when I give this 7,000 rpm and 110 newton meter of torque in the formula, I'm obtaining about 70 kilowatt of power.
Okay.
But the prime movers kilowatt is about only 10 kilowatt. Like I need to understand that the manufacturers used to say this is a 10 kilowatt motor, this is a 20 kilowatt motor. Is that the ideal case of representing those motors, or are they representing the peak power that a electric motor can achieve?
Yeah, I think they are talking about the peak power. Okay.
Okay.
Because you will not get that much power at full RPM. Okay.
Okay.
So there are differences in that regard.
Okay, sir.
Uh, so if you look at the torque curve,
Okay.
I'm trying to find one for you while I'm talking. So uh,
Okay.
so in such what do I say? So there are two kind of curves we look at: power versus RPM and torque versus RPM. So you'll not get both at the same time. Uh, right. So maximum torque and maximum RPM is something which is not going to happen at the same
Yes,
time.
sir.
I mean, okay.
Yes, sir. Yes, sir.
So, uh,
Oh, okay. I understood your point, sir. Like the 7,000 RPM is not gonna be
yeah,
achieved at 110 newton meter of torque. It is both are the peak torques and the peak RPM.
correct. So
Okay,
yeah,
okay,
I
okay, okay.
found something for you. Let me just share it on the screen.
Okay, sir.
Okay. Yes. So this is from one of the manufacturers. You can see performance curves, right? Can you see the
Yes, sir.
torque versus RPM?
Yes, sir.
So
It is
you'll
visible.
uh, okay. So this is what I think the one they are selling is shown in the orange or yellowish color. So the
Mhm.
maximum torque, see, electric motors are capable of providing high value of torque at 0 RPM, right?
Yes, sir.
Which IC engines are not. So it will give you the maximum torque up to say 1500, 1600 RPM in this particular case,
Mhm.
12,000 Newton meter torque, and then it will start decreasing as you are increasing the RPM. So if you want the full torque at full RPM, that is something which no motor will give you.
Okay, sir. Okay, sir. Fine.
Okay,
Yeah,
so
I could understand.
all right, so I hope that helps.
Yes, sir.
Okay, then all right, so okay, uh, more questions?
Sir, is there any way to, simulate the power consumption of a gearbox, sir? Any of the simulation softwares?
Uh, if I remember correctly, there is one simulation software called uh, wait, oh, AVL Cruise.
AVL Cruise, sir?
Yeah, uh,
Okay.
uh, wait, I've typed it there. If I hope
Okay,
my
sir.
spelling is correct, but AVL Cruise is one of the softwares which allows you. There is something free software. Also, it's called something advisor. I don't recall it over top of my head.
Okay, sir.
Okay, but yeah, there is one soft. You search for free softwares for electric powertrain simulation. You will find it. Okay.
Okay, okay, sir.
Yes, yes. So that is the keyword you can look for. AVL Cruise, I think, is a commercial software.
Okay, sir.
Okay, but I think you will find some free version. You can always
Uh,
look up for free Simulink, MATLAB Simulink models. If
okay,
you don't have MATLAB access, then maybe look at Scilab, which is a free Scilab XCOS, which is a free version similar.
okay, sir.
Okay, yeah, you
Uh,
should be able to find something on that.
where I can I can put my model inside and get the outputs. Is
Yeah,
that
yeah,
like
yeah.
that? Okay,
Yeah. It depends mostly on you and how you are writing the model, right?
okay, sir.
Computer tools are secondary.
Okay,
If you are
yes, sir.
writing your own, if someone else has done the research for you and given you good models to work with, by all means utilize them to your benefit.
Yes, sir.
Okay, all right.
Yes, sir.
So, so we will be
Sir,
solving numerical problems later, not today, but some in few next sessions, wherever there is need. Okay, yeah. Sorry, continue.
yes, sir. One more doubt, sir.
Uh-huh.
Like I had an idea, I don't know whether it is existing or not. Like with a shaft with a gear. Okay.
Hmm.
Can I mount that gear on the shaft with a bearing kind of thing between the bearing contact between the gear and the shaft?
Wait, you want the gear and shaft must be coupled together. No, you can't add a degree of freedom like a bearing there. If you add bearing there,
Yes, sir.
then the torque transmission won't happen, right?
Yes, sir. That is what I need, sir. Like
It
at
won't
a
happen.
like what I'm asking is like when for an application I need what to say like I the gear must not transmit the torque to the shaft. I should I should um, what to say
Hmm.
I should break the linkage between these two. So
Or
that's why at the desirable conditions only it should uh, um, like it should transmit the torque
yeah.
giving a
Yes.
flange extra there and doing it.
See, that's why we use clutches for, right?
Yes, sir.
So, no, the purpose you're describing is essentially solved by a clutch.
Yes, sir. Actually, if a clutch is there,
Hmm.
can I mount it on the two independent shafts, sir? Like directly through a keyway kind of thing, and just uh, mounting it.
Yeah, you can add a clutch between two shafts, right?
Okay. Yes,
Uh,
sir.
they are assuming they are in line,
Mm?
right?
Yes,
If
sir.
you want it to be RPM specific, right? Like
Okay.
below certain RPM, I don't want my motor to move. After
Mm?
certain RPM, I want it to move. Okay.
Mm?
Then that is what the clutches in our scooters do, right? Scooter does not have
Okay.
a, if you look at a bike and a scooter will not have a lever to, you know, give clutch input.
Yes, sir.
So it will be spring loaded, and when the engine is rotating, the clutch will rotate with it.
Okay.
Once you reach a certain level of RPM, right,
Yes,
there
sir.
are some pads which are held together by spring. So
Okay.
as you increase the rotation, these the centrifugal force acting on those pads will act against those springs, and at some point that contact will happen between the inner shaft, right, between the
Okay.
inside of the clutch and outside of the clutch.
That is the centrifugal clutch.
Yeah, that is
Uh,
the centrifugal clutch. So
yes, sir.
uh, mm, that would help in what you were thinking.
Uh, my application is like what 0 RPM. I should engage the clutch,
Uh,
and also the shaft should not transmit the torque. That is what the idea of interest.
okay. Perhaps we can experiment with concepts. I,
Yes.
right. What you have available, you just, for example, even if in this notes you can scroll through, you might find some different types of clutches. See what fits your use.
Okay,
Right.
sir.
It's by and large like portfolio engineering where you have list of products which you can utilize. See which one fits the best for your need. If none of them, you have to design your own, but one of them will fit good enough for your purpose.
Okay, sir.
All right, man. So,
Sir,
yes.
in this module, is there the coverage on the positive clutches, sir? Like conventional friction clutches are usually taught in the college syllabus.
Okay.
Will there be covering the positive clutches design and so in this module, sir, in the fundamentals of
See,
automotive
I
systems?
am a brakes fellow, and I do not deal that much with mechanical design. I am more on the algorithm side in my
Okay.
personal journey of work. So, the idea of this course is to enable you to get familiarized with general ideas behind these topics like engines and powertrain, the transmission, and so on, so that you will be able to relate to the new technologies which are coming in and understand and improve your understanding, right? So that is the goal behind this course. It's at the end, it's a fundamentals course, right? It will get your basics covered so that you will be able to take your own leap. To answer Vijay's question, I think yes, we are digressing too much into transmission. We will be dealing with these kind of ideas when we do module on transmission.
Sure, sir. Thank you, sir.
All right, thanks. All right, so uh, we have more questions. I think we have around what 10, 12 minutes left for the 2 hour session. So uh, yeah, I'm very happy that I have so many questions being asked today. Last time we were doing control systems course similarly. Unfortunately, not many people are joining. And I think looks like this course has much more pull and uh, work right, like into it. So I hope I'm trying to do my best to answer all your questions. Unfortunately, some of them I may not be able to answer, where I will go back, discuss with my colleagues and the professor, and try to get back to you with either written answers or we can discuss them next week. That's also perfectly fine with me. So, module present in aircraft that is pistonless engine. Yeah, Indranil. So those the aircraft engines are, yeah. So the aircraft engines, the one which do not have piston, are right. The turbine engines are they are okay. So in that case, we do not have piston, but we have a compressor and then a combustion chamber uh, and what is the third stage called? Something to pull air in. we burn it, we get the fuel air mixture burnt, and the air is coming at high pressure. So it no, we do not have that in our course, unfortunately. But I think you can find really good references on that. First, to get started with understanding. So idea there is to have compressed air at very high pressure, mix it with fuel, burn it, and use the kinetic energy in the exhaust to run a turbine. Then the same turbine ends up rotating the compressor. So, this mechanical energy transmission cycle continues. So the energy from combustion is utilized in two ways. First is to compress more air, right? So a positive feedback is there. And secondly, to push the air pushed out would generate the thrust. So supercharging principle is it's a different story, right? Supercharging or uh, called turbocharging, that's, yeah, I mean, in principle they are similar, but a way in which jet engine operates and the way in which supercharger operates are slightly different. In supercharger, it's a passive device, right? You will start getting the benefit of supercharger after reaching minimum vehicle speed, and uh, whereas in the right, the active combustion is not driving the supercharger, versus an active combustion is driving the uh, jet turbine. So that is, in my opinion, a fundamental difference. All right.
Sir, we have to do assignment.
Sorry, I
Sir,
cannot hear.
we have to do assignment.
Yeah, the assignments are here, right? If you go in the course, uh, okay, wrong. So there are weekly assignments which you are expected to solve, right? Due dates are given here, so kindly try to follow through those. These assignments would help you understand things better. You can go in and look at these handwritten notes to find answers to these questions. By and large, the answers are there in the notes. This sessions we will utilize to solve some more problems, right? The larger problems. Uh, some of them may or may not be part of notes. So at the end of each module, right, if I may go to the first page here. So the course structure is as follows. We have a module, right, on powertrain, brakes, steering, suspension, wheels, and tire. And the module is structured in three parts. First is components and realization, uh, then the operating principles or operation, and some level of mathematical analysis. By and large, the questions we are asking will form in the all three categories, but the numerical questions we are asking are stemming from the analysis segment. Okay. So towards the end of the module, for example, the engine module lasts for first 5 weeks. So sometime we will have general discussions like we had today. Sometimes I will come in with specific problems which we will solve together for some time. I will try to ensure that we limit the problem solving time to roughly 1 hour, so that you guys can ask me the questions you are facing, like we did today. I'm extremely happy with today's session. So uh, somewhere mix and match of all things, and a little bit discussion on topics which are not covered in this particular course, like the module on electric vehicles. So these things I will talk with my team, and we will certainly do that in these sessions. Okay. Thank you, Sachin. So I had wonderful time with all of you, and I request you to uh, try attending upcoming sessions. As from today's discussion, I will get back to everyone on desmodromic valves and heat plug function, right? Heater plug function. My YouTube channel will be live, and if you do not receive any communication in the meantime, certainly I will show you my YouTube channel next week, and we'll talk about the questions we have, and unfortunately I could not answer. And next week we will go live on one module on electric vehicles. We'll start somewhere. Okay, so I think that summarizes everything. So do we have more questions, or shall we? I'll wait for 2-3 more minutes. If you have questions, kindly raise them, or we can close the session. If you don't have any further questions, you may. Yes, Pawan.
Sir, for assignment, we have to follow first notes, then we have to solve the assignment.
Assignments, you start looking at them. There are unlimited attempts allowed for you to, mark answers for the questions. So the notes will help you in solving the assignments, right? These notes are from the class itself. And what I can assure you, knowing uh, our way of teaching, you have to look for it. You will find almost every answer in the every question asked in the assignment. The answer will be there in written notes. Uh, that I can assure you in good faith.
Sir, assignment one is which date will.
See, due dates are written here. Okay, unfortunately, 8th. So yeah, in next 2 days you must do assignment 1 and 2. It seems. Okay. So I don't know how NPTEL is scheduling these sessions. So by now, actually, we should have done 2 sessions, but here we are. So week 2 we will discuss things, but answers are you will be able to solve all these questions looking into these notes. Okay. Uh, all right. Uh, let me copy. So if there are no further questions, I think thank you for participating in today's session. I had fun. I request all of you to come back with more questions, and we will have our discussion on electric vehicles. All right. Uh, so yeah, thank you.
Thank you.
Thank you, sir.
Thank you.